So these two are cancelled, but the bottom one is not. So the dipoles are not all cancelled. Some are cancelled, some are not all cancelled. So in this case, I still have a winner. So the molecule is polar. So it's still dissolving water because it's not all cancelled. So I still have a dipole present around. So still polar. The polar molecule, the dipole one that is still present is this one. Okay, the one on the bottom. These two are cancel each other. And so number 3. Okay, I do have 5 bonds. Okay, 1 bond, 2 bond, 3 bond, 4 bond, 5 bond. This is not called 2 bonds. This is called 1 double bond. So I got 1, 2, 3, 4, 5 cancel bonds. So if you look up C and C, the difference is 0, so no dipole. C and H, the difference is 0.4, no dipoles. So here the bonds are 5 non-polar. Okay, 1, 2, 3, 4, 5, no dipole, non-polar. So the dipoles are not present. I don't even have them, not present. So because I don't have a dipole, the molecule will be non-polar. So it's not going to be dissolving water. Now here, P is 2.2, F is 4.0. So I do have to draw the dipole because the difference is 1.8. So I have to draw from P to F because F is bigger. So I got 1 dipole here, 1 dipole here, 1 dipole there. They're all the same kind. 1.8, 1.8, 1.8. Alright, now here I want to use a green pen to circle this. This is a lone pair around central atom. I do have to draw this. Okay, I have a central atom with the lone pair. So this dipole, I'm going to draw the green color, and then I'm going to say leftover electron on central atom. Leftover electron on central atom, I will need to draw dipole. So now you can see I do have 3 polar bonds. Okay, this is not a bond, this is just a dipole from the leftover. So the bonds, I do have 3 polar bonds. Right. Now the dipoles, these 3, first of all, these 3 direction, they are like a chicken feet direction, they don't cancel each other. Plus, this one, the green one, is not the same kind of dipole as the red color. That's why I use a different color to represent. They're not the same kind. So this is actually not even cancel each other because they're not the same kind. So here, the dipoles are not canceled. Dipoles are not canceled. Okay, so because the dipoles are not canceled, I will have the polar molecule, so it will be yes dissolving water. And then here, 2.5 and 2.1, the difference is 0.4, so that's nothing, right? So no dipole. So that I do have 4 bonds, so 1, 2, 3, 4. So it will be 4 non-polar bonds. And the dipoles are not present. I don't even have dipoles. Not even present. So that the molecule is non-polar. So it's not dissolving water. Now here, N to H, the difference is 0.9. So 0.9, 0.9, 0.9. So it will go from H to N because from small to big. The dipole from H to N. And they're the same kind. H2N. Now I do have a leftover on the central. Alright, so I'm going to draw this. Okay, now you can tell I do have the bonds. I get 3 polar bonds. Alright, the green one is not bond, the green is just left over. Now the dipoles, you can tell one goes up, one goes up, one goes up, this also go up. So everybody actually going up. So they actually combine. I'm going to draw a big, giant thing. Okay? Because, alright, this go up, this go up, this go up, this go up. So everything goes in the same direction. I finally draw a dipole, like a combined one. So actually, the dipoles are combined. So I'm going to use black pen to represent. The dipoles are combined. And then I'm going to highlight this. The dipoles are combined. The dipoles are combined. All right. So in this case, I do have a winner because the dipoles combine. That means all the dipoles go to the top and nothing on the bottom to cancel. So the molecule is polar. So yes, dissolving water. And then here, C to Cl is, the difference is 0.5. C to Cl 0.5. C to F 1.5, C to F 1.5. So we have two kinds of the bonds, right? C to Cl is one kind, C to F is another kind. So I'm going to use the red pen to represent the first pair of the thing. And then I'm going to use a black with the thicker one. Right? The thicker one, meaning the bigger delta En, because the F and C, the difference is 1.5, so it's bigger delta En. C and F, the difference is 1.5. So I'm going to draw a thicker dipole to represent a bigger delta En. C and Cl, the difference is only 0.5. So I'm going to draw a red color dipole with smaller, like thinner. So now you can tell I actually got 4 bonds, but I have two kinds of the bonds. I got 2 polar bond, it's one kind, and then I got another 2 polar bond. Now you don't want to write 4 polar bond. If you write 4 polar bond, that means represent that they are the same kind. They are not on the same kind. They are not. So in this case, you can tell these 2, right? So that this and that, these 2 are not the same kind, right? They are not the same kind. They cannot be cancelled. These 2 are not be the same kind. They cannot be cancelled. So then dipoles are not cancelled. Dipoles are not cancelled. All right. But black and red cannot be cancelled because they're not the same string. Black and red, they are not the same string, so not cancelled. So the molecule is polar. So yes, dissolving water. And then finally here, CNH no dipole, CNF dipole, CNF dipole. All right, so here I got 2 polar plus 2 non-polar, right? Because I got 2 dipole and 2 no dipole. So then you can tell, right, the dipoles are not cancelled. All right, so then it will become a polar molecule. So then it dissolves in water.